In this video, we're going to talk about the chi-square distribution because we're going to need it to understand the goodness of fit tests using the chi-square distribution and test for independence later. Where does the chi-square distribution come from? Well, basically, we know that the sample means follow a normal distribution and sample proportions also follow the normal distribution. There's something called a sample variance. Remember, the sample variance is the sum of the difference between the observed value minus the mean, or n minus 1. In fact, the sample variance distribution is the sampling distribution of the sample variance, in fact, uh, follows a chi-square distribution with n minus 1 degrees of freedom. Okay. Just like the normal distribution, the sample mean distribution follows a normal distribution, sample proportion distribution follows a normal distribution by central limit theorem. Similarly, you can define a sampling distribution of the variance, okay, and it actually follows a chi-square distribution with n minus 1 degrees of freedom. So what's the chi-square distribution or function? And, well, not to get into too many specifics because it's too complicated. The chi-square distribution is a constant times x with n minus 1 degrees of freedom. Looks like x to the n minus 1 over 2 times e to the minus x over 2. Then the graphs actually look like this. So they go exponentially to 0 and infinity, and then they start off at 0. So these are different graphs, the chi-square distribution for different degrees of freedom. Nu, remember this is nu, Greek letter nu. Okay. And because the function is so complicated, it's hard to actually find the analytical closed formula for the areas underneath this function. So, like the standard normal distribution, we find areas numerically and just use tables. So this is the table of chi-square distribution. Uh, and on the left hand side is the degrees of freedom. On the top row is the area to the right of a certain x alpha nu. Just familiarize ourselves with how to find areas to the right of chi alpha nu. Okay, so for example, for a chi-square distribution A, find the chi alpha squared such that probably chi squared is greater than chi alpha squared. A is equal to 0.99 when nu is equal to 4. Okay, so let's do A first. So here, our degrees of freedom is 4, and the area to the right of this chi alpha is 0.99. So let's look at the chi-square distribution table. So nu is equal to 4, so we find the nu here. So we go across. Let's go across. And then on top is the area to the right. Okay, so it's 0.99, right? So then we go down. And again, like the standard normal distribution table, we just find the intersection. So chi alpha squared here is 0.297. Yes. Chi alpha squared here is 0.297. How about B? Find a alpha squared such that probably, again, same thing, chi squared is greater than chi alpha squared is equal to 0.025 when the degrees of freedom equal to 19. Okay, so now let's look at the chi-square distribution table. look for 19 degrees of freedom. It's right here. Go across. Then we look for 0.025. Alpha equal to 0.025. So 0.025 is here. You go down, and the intersection is this coming here. 32.852. That's 32.852. So chi alpha squared here is this. Now for C, find the chi alpha squared such that probably that chi squared is in between 36.65248 and chi alpha is 0.045. Okay, so let's draw what's going on. So we have our chi-square distribution with here 25 degrees of freedom. So it basically just looks like this. And then here we have a 37.652, and in between, and then this chi alpha squared. So in between here, the actual area is 0. Here is 0.045. Okay? So we need to find this chi alpha. Well, for 25 degrees of freedom, if we look at the chi-square table, 25 degrees of freedom, there is a 37.652 here, which means when we go up, we see that the area to the right of 652 is 0.05. Okay? So that means that 0.05 minus the probability chi squared, right, is greater than chi alpha squared. This is going to be this little area here. This represents this area to the right. It must be equal to 0.045, which means that probably chi squared and chi alpha squared is equal to 0.05 minus 0.045, just 0.005. That means that chi alpha squared, okay, so looking at the chi-square distribution table, 0.005 is here, and we have to just continue on with this 25 degrees of freedom to get that chi alpha square must be 46.928. 46.928. Okay, that's how we work with the chi-square distribution table.